All right, so this is the first one. This one is just in standard form already. There's no shifts horizontally or vertically, which means your vertex is at 0, 0, and then I would plug in something to the left and something to the right. So if I plugged in, which is what I did, -1, you got -1/4, and you plug in +1, it's positive, or it's also -1/4, which should make sense because that's symmetric. Which means that your axis of symmetry would be at x equals 0. On this kind of question on the quiz, you would also want to know, you would also want to be able to do domain, range. So it's going to ask you for intercepts, domain, range, all the like parts of it. So if I ask you for domain of this graph, you tell me it's what? All real numbers, negative infinity to positive infinity. That is true for every single parabola. Okay. How about range? Good. So it doesn't ask for it every time, but think, could I do this on every single graph? Because that's what it would be good practice. All right, second one was number 8. So you wanted to do the negative b over 2a here. Negative b over 2a gave you -1 because it's -4 over 2 times 1. And you'd get 2, plug that back in, and you get -1. This is the plugging back in here. And that means the vertex coordinate would be 2, -1, which means the axis of symmetry is x equals 2. The x-intercepts came from down here. I can actually factor this time. You would have factored as x minus 3 and x minus 1, and you get 3 and 1 for the x coordinates of those. So it would be 3, 0, and 1, 0. You could also do quadratic, but obviously if it's factorable, it's quicker. Then the y-intercept is here. Okay, you plug zeros in for the x's. When it's in quadratic form, it's super easy. It's just that last term, whatever that c would be. So it's 0, 3. And then plotted those 4 points, and it was enough information to draw my parabola. Domain here, also negative infinity to positive infinity. Range this time would be -1 to positive infinity. Questions on that one? All right, and then the third one, using complete the square, you have to group the 2x squared plus 8x together, and the 7 goes on the outside. You have to take 2 out of it, so you end up with x squared plus 4x inside the parentheses. take the 4, divide it by 2, and square it. It's 4. You're going to add the 4 inside the parentheses, and then you'd normally subtract it from outside the parentheses, but because we took out that 2, we have to multiply it by the -4 first, and you end up getting -8. So if you were to rewrite this, it would be 2x squared plus 4x plus 4, and then positive 7 minus 8, which is -1. You want to factor your trinomial, so the 2 stays on the front. Square root of x squared is x. Square root of 4 is 2. Put in the parentheses, square it, take the sign from the middle, and then subtract the 1 at the end. So that's the standard form of your graph. From there, it's easy to get the vertex. It'd be -2, -1. Axis of symmetry would be x equals -2. The x-intercepts, if you use the initial one, it wasn't factorable, so you would have had to use quadratic. If you use the standard form, that's what's here on the left-hand side. So it would have been 0 equals 2 parentheses x plus 2 squared minus 1, added the 1, divided by 2, square rooted both sides, and I end up with plus and minus this 1 over the square root of 2, and then subtract the 2. And these are your exact x-intercepts. So if the question says find the x-intercepts, you're going to give the answer in its exact form, which means the square root stays in it. So it'd be -2 minus root 2 over 2, 0, and then -2 plus root 2 over 2, 0. Now when I go to graph these, I have to approximate. So root 2, you could approximate to be like 1.4. You could do 1.6. It's not going to make that big of a difference. And you could even do 1.2. Again, it's not going to make that big of a difference. So then you could divide that by 2, it would be -2 minus 0.7, which is -2.7-ish. Again, this is an approximation. And then -2 plus 0.7, which would be -1.3. So when I go to graph those, that's the point that would be here and here. Obviously, my vertex is exact. It's there. And then the last thing I wanted you to find was the x-intercept. So again, go back to where it's quadratic. It's way easier there. The zeros cancel out the first 2 terms, and then it's just 7 for my y-intercept. Plotted the 7 and connected them to make it.
How would you know this means standard form?
I told you to complete the square at this, but the instructions on the quiz would say that. If it didn't, you'd have a choice. You could either do -b over 2a, or you could do this way. But it will specifically tell you sometimes to complete the square. Yeah. And on every question on the homework, once you get past, like the beginning ones are like our beginning ones where you just have to find the vertex and then plot the points. But then it gets into put it in a standard form every single time. And then answer questions. Questions on this one? Yeah, oh, sorry.
What would you subtract the 8 in the second part?
So normally you're subtracting 4, right? Whatever you add in here, you have to subtract from out there. But there's a 2 on the front. Whatever you take out has to get multiplied by what you're going to subtract before you subtract it. All right, so now we're flip-flopping it. Now you're going to get given the vertex and a coordinate point, and then it's going to say, give me the equation. So it's super easy. You are plugging in the vertex into your HK. You're plugging in the point into the XY. You'll only have one variable left, which will be the A. You'll solve for A, and then you'll take and plug back into this equation the vertex, where your HK is, and the A. So your equation at the end would be y equals, there will be a number here, x minus or plus a number, squared, plus or minus a number. So those 3 spots will be filled in at the end, okay? So again, you're just working in reverse. The most important thing here is to remember your equation, the a times x minus h squared plus k. And the questions will look something like this, okay? The vertex is 1, 3, and it passes through 3, -6. The directions would say find the equation in standard form. So this is my h, and this is my k, and this is my x, and this is my y. You cannot reverse those. It's important that the vertex is the vertex and the point is the point. And then I'm going to plug it into y equals a parentheses x minus h squared plus k. So the y is -6. The a is our unknown. The x is 3. The h is 1. And the k is 2. Negative 6 equals a times 2 squared plus 2. Negative 6 equals a times 4 plus 2. Negative 6. And you can rewrite that as 4a if it's easier for you to read. Subtract the 2. Negative 8 equals 4a. Divide by 4. And a is negative 2. Now we go back up again and we plug now the a, the h, the k. So it would be y equals negative 2x minus 1 squared plus 2. And that's your answer. So equation in standard form. Same question for 11. This would be my h, this would be my k. The negative 4 is my h, the 11 is the k. The negative 6 is the x, the 5 is the y. Plug it in. So y equals a parentheses x minus a negative 4 becomes plus 4 squared plus k, which is 11. 5 equals a times negative 2 squared plus 11. 5 equals a times 4 plus 11. Subtract the 11. Negative 6 equals a times 4. Divide by 4. And a is negative 3/2. Then take and plug back in. So y equals negative 3/2. X minus a negative 4 becomes plus 4 squared plus 11. All right, so I'm going to teach you how to plug this in again to the graphing utility. You don't need to do this. This is just so you could like check your answers, that kind of thing. This is just to help. The great thing about these is that obviously in a standardized test, you can use your handheld graphing utility. So it's a good thing to learn how to use. So if I wanted to graph the equation, I'm going to hit y equals in the top left corner, and then I'm going to type in the equation. So the one we're going to do is that 2x squared plus 8x plus 7. I hit enter. I hit graph. Oh, my window's very zoomed. Sorry, I had to use this. Yours. Looks like this. Okay, which matches what we drew for this question. Let's say from here I wanted to find the vertex, okay? The vertex is the minimum point on this graph. So I'm going to go second, trace, and I get this menu. Notice vertex is not on there. So you'd have to know that the vertex is that minimum point. I go to minimum, and it says left bound. So I have to go left of my minimum on this curve, anywhere left of it. So as long as I get past it, that's fine. I could go all the way over here. It doesn't matter. But as long as I'm left of it, I hit enter. And then it says right bound. So I go past it now on the right. And again, anywhere on the right is fine. It doesn't matter how far, as long as you're right. And then it says now, are you ready for me to guess? I am. So I hit enter again. And it's going to bring me right to my minimum. So that says negative 2.00000002, okay, which would round to negative 2. And then your y is negative 1, which is where the vertex is, okay? If you wanted to know your x-intercepts, the word for that in this is 0. So the 0 is where it crosses the x-axis. If I go 0, now there's 2 of them, which is why that left bound, right bound is important. I want the one on the left first. So I'm going to go left of it. I'm going to go right of it. You can't go past the second one. And then I hit guess. And it brings me to that. So that negative 2.7, remember that's when we approximated, okay? And then I do it again, second, trace to get to that calc menu, go to 0. Now I want to go left of my right 0, anywhere over here. I go right of it, anywhere past it, and I guess, and it brings me to that one, which is like negative 1.3. So I want to stress, like, you don't have to do this on this quiz. When we get to like higher degree functions, they're going to go up and down, up and down. You'll get a test or a quiz where you have to use your graphing utility to find that stuff. For right now, it's simply just to be able to check your answers, okay? Questions on that? calculator. So we're going to do it on the app. So if it said to use the graphing utility, which is what we just did, we screenshot this, and then Vertex and Intercepts, this coordinate point here was 2, -1, and then these points were 1, 0, and 3, 0. Those would be your intercepts. And then over here is 0, 3. That's the other intercept. Equations. It says put the equation into standard form, then find the vertex, Y-intercept, X-intercept, and axis. So standard form, again, means complete the square. I'm going to group together the first two terms. Bump the 4 with the negative on the outside. Now there's a negative on the front here, so I have to take that out. It's got to be a positive 1 at the front. So when I take out a negative off the x squared, it would also come off of the positive 3, which means this becomes negative 3x. Then I'm taking 3, dividing it by 2, and squaring it. 3 obviously is not even, so it doesn't go in evenly. I would leave it as 3 over 2 squared, which would become 9/4. I would add the 9/4 inside the parentheses, and I would normally subtract the 9/4 from outside the parentheses. But because we took out a -1, we have to multiply by that -1, and that changed this to a plus 9/4. So I'll rewrite it. Negative x squared minus 3x plus 9/4. And -4 plus 9/4 becomes -16/4 plus 9/4, which is -7/4. With me so far? Okay, negative stays on the front, and now I factor it. Square root of x squared is x. Square root of 9/4 would be 3/2. Keep the sign from the middle, which is the minus, put it in the parentheses, and square it, minus 7/4. So here's my equation in standard form. What's my vertex? Good. 3/2 and -7/4. My axis of symmetry, x equals 3/2. For x-intercepts, I'm going to take and plug 0 in for y. 0 equals negative x minus 3/2 squared minus 7/4. I'd add the 7/4. I would divide by -1. And I end up with -7/4 equals x minus 3/2 squared. Oh, that's really hard to read, sorry. And I would go and square root both sides of the equation. What happens when I try to square root -7/4? It's an imaginary number. Can you graph an imaginary number? No, so there would be no x-intercepts. If you had tried to, it wouldn't have been factorable, but if you had tried to use the quadratic on the initial one, the same thing would have happened. Underneath your root would have been a negative number, and you can't square root the negative number. So then the last thing I want to find is the y-intercept, and this one, remember, we go back to where it's quadratic. At the beginning, this would be 0, 0, and it's just 0, -4. So if you think about the graph of this equation, like it doesn't say to graph it, right? But let's think about if it did. I would have plotted my vertex, which is 1 1/2, and then -1 3/4. So I would have gone down here. And it would have been negative, which means it points down, which is consistent with the fact that it doesn't have x-intercepts, right? If it doesn't have x-intercepts, this shouldn't open up because then it would cross through the x-axis. This is opening downward because it's negative, okay? The only other piece of information I have is my y-intercept. So I would know it would point down, and then it would be consistent with what I found. If I wanted to graph this, you would have had to plot at least one other point. So you need at least 3 points, 1 being your vertex, 1 to the left of your vertex, which is the y-intercept you already have. Oops. The y-intercept. So if I wanted to graph something, I would plug in something to the right of my vertex to get that other side. Okay. It didn't say to graph this time, but if it did, you would need to plot an additional point if it doesn't have x-intercepts. Questions? Yeah.
Is that top point at the 1 or like in the middle?
This one is that 1.5 and negative 1 and 3/4. Yeah.
So if you get the y and x-intercepts right, but we like graph it wrong.
You'll get partial credit. Yeah, we'll take that because it's really, I think it was right now it's like 4 quiz wise it's like 4 questions but there's multiple parts to each question, so it'll get broken down. You just got to be really careful when you're completing the square, because if you complete the square wrong, everything after that becomes wrong. Yeah. It's not like you're going to lose full credit on it. Like, we'll probably base on the fact that you got a wrong equation, but you can't get the full credit. So just be really, really careful.